This tutorial explains the difference between scalar, vector, and matrix in the context of Matlab. If you haven't done so, make sure you create a new folder for lab 2 or whichever lab it is. So go to the folder where your lab folders are, and then right click in the current folder view, and then here you can add a new folder named lab 02 or whichever lab you're working on, and then go into that folder. Now talking about scalar, vector, and matrix, first of all let's talk about what is a scalar. So you know from your math that scalar is something that only requires a single number for specification. So for example, s is equal to 2 is a scalar. If you look at the value, it has only a single value, and that describes the scalar. You can also look at it as something that only requires one number to specify. For example, temperature, the mass. But a vector is something that requires more than one number. So for example, in 2 dimensions, a vector describes position and has 2 components, x and y. In 3 dimensions, a vector describes 3-dimensional information that has x, y, and z component. So for example, I could have a vector with 3 components, and in Matlab we put these components inside a square bracket. So let's put these values. Let's say along x-axis we have 3, along y-axis we have 4, and along z-axis we have 5, and these are all comma separated to form a vector. Okay, if we look at this, it creates a small array of 3 values in a single variable named uppercase V, and this is one way of describing a vector. Now it doesn't have to be 3 components. I could create another vector v1 which may have more than 3 components. As you can see, another vector with more components has been created. And if you anytime display this vector, it shows as a row, and that's why it's also called a row vector. But I can also create a column vector by same method, but the numbers are separated by semicolon. So if I separate them by a semicolon, and now I look at this vector, it has created another vector. It's a column vector, and now it has 3 rows and 1 column. In this case, we had 6 columns and 1 row, and in this case we have 3 rows and 1 column. And then in a similar manner, I can also create a longer column matrix. So column vector. Both of these are vectors, and in Matlab often we can also call them matrices, but technically this is a column vector, this is a row vector, and if I want to define a matrix, I will have both columns and rows more than one. So for example, I could have a matrix which has first row 1, 2, 3, and then I can start a second row by separating by a semicolon, and then add another row 4, 5, 6. And as you can see, this has created a matrix M which has 2 rows and 3 columns. And let's say you come across a matrix, and here it's pretty straightforward. You can visually see, and sometimes there's so many values that Matlab cannot display it here. In that case, you can use a built-in function called size. And if I put size v, which I created earlier, you will see that it has a size of 1 row, 3 columns. But if I do size C, it's 3 rows, 1 column, and size of M is 2 rows, 3 columns. So hopefully this will give you an idea that how the matrices are represented, vectors and matrices are represented in Matlab. All vectors, row vector, column vector, matrices fall in a general category of container type or variable type called array, and they're all multidimensional arrays. And it doesn't have to be limited to 2 dimensions. I can create a matrix that has 3 dimensions. So you can think of this as rows, columns, and then there could be layers that form the 3rd dimension, creating more of a cubic matrix. Some of the things that also you may want to know is that how do you multiply, add, subtract matrices. So if I have 2 scalars, S1 and S2, I can simply add them and I get the sum. I can multiply them and I get the product. But if I have vector 1 and vector 2, and if I want to multiply these 2 vectors, if I try to do this, I am going to get an error. And it's saying that the matrix dimensions must agree. And this potentially is trying to do matrix multiplication, which we cannot do. But if I want to multiply 1 with 4, 2 with 5, 3 with 6, I'm trying to get an answer called 4, that can be said 4, 10, 18. It's also called element by element multiplication or element by element arithmetic between 2 vectors. That can be done by changing all of the arithmetic operations to dot and then the operation. So for example, if I do dot multiply, this I'm saying that multiply v1 with v2 by element multiplication. As you can see, we will get an answer 4, 10, 18. Similarly, I can do divide operation, raise to power operation, and all of these are doing taking the first element and operating it with the corresponding first element of the second vector, second element with the second element, and the third element with the third element, and so on and so forth. This arithmetic operation called dot operation applies to row vectors, column vectors, and matrices and multidimensional matrices. One thing that you have to be careful about is that the 2 vectors must be the same size. Let's say v2 was the way we defined here. You can do up arrow to go back to that line. Let's say our v2 was only 2 elements, and we try to do this multiplication again. You will see it say that the matrix dimensions must agree. These 2 matrices must be exactly same size for this operation to happen. Matrices are very powerful. You will see in the rest of the course we will create all sorts of matrices and vectors and rows, because then we can have many values under a single variable name and then use that name to create new variables and write equations that can use multiple values at the same time to run an operation. This concludes this tutorial.